Hello, everyone. I'm going to let some folks join in for just a moment more, and then we'll get ready to kick this off. Okay, let's get this started. I'd like to say we're very glad to be joined by our partners at LINBIT as we spend some time to review how to run a hyper-converged cloud with OpenNebula and LINBIT software-defined storage. We also have the pleasure to be joined by an OpenNebula champion of ours from WEDOS Internet. And he's going to be reviewing some of the details of their particular success story with both. Okay. So if you haven't joined us previously in one of these events, this is our webinar series, which we've been carrying out through most of 2020, and which we're going to continue to promote, really with the goal of creating interactive events for the community. So our hope is going forward, you'll keep a close eye on the developing events calendar, right? And that you'll join us for future events whenever you can. Okay, so this here is a quick lineup of the folks who are joining me here today. I'm Michael Abdu. I'm the Customer Success Manager at OpenNebula. I'm joined by my colleague, Tino Vazquez. He's the lead cloud engineer and engineering manager at OpenNebula. And once again, we're glad to have Yusuf Yildiz he's a solution architect from LINBIT. And we're also joined by Andre Kvapu, a cloud architect and DevOps engineer at WEDOS Internet. Okay. Okay, and this here's the agenda for today's session. I'm going to start off giving a short introduction to OpenNebula, and then I'm going to hand things over to Tino. He's going to review OpenNebula's open architecture and storage support. Then Yusuf will present LINBIT's SDS solution, and then we'll wrap it up with Andre running through an overview of what he's doing running OpenNebula and LINBIT at WEDOS Internet. Okay. And then we'll wrap up the session with a Q&A session. We'll ask all of you to send your questions through the chat. If you can, hold on to them and send them, towards the end as we're getting ready for the Q&A session, that usually works out better. Okay. Okay, so I'm going to give a short intro to OpenNebula. So for those of you who may not know or are just getting introduced to OpenNebula, OpenNebula is a simple, feature-rich, flexible solution, right? That's used to build and manage enterprise clouds, right? That combine existing virtualization technologies with advanced features for multi-tenancy, automatic provisioning, and elasticity to allow you to offer on-demand virtualized services and applications. So, it's an open source solution. This here is just a quick kind of look at the dashboard, the Sunstone interface that both users, admins, and architects have access to. Okay. What's unique about OpenNebula compared to other cloud orchestration software solutions is that it provides really this single pane of glass, right, to one's entire enterprise cloud. So It provides the flexibility to run any application, right? Combining containers, right, with virtual machine workloads and in a common shared environment to offer really the best of both worlds, both the maturity and security offered by virtualization technology, along with the agility and speed of container orchestration. Okay? It also allows the utilization of any infrastructure. Right? You have the ability to unlock the power of what we're calling a true hybrid and multi-cloud platform by combining the edge public, right, hosted as well as private cloud operations. And it also provides, the support for any virtualization, allowing you to integrate multiple types of virtualization technologies to meet your workload needs, from fully virtualized to system containers and serverless applications. So, all of this put together, in one open source solution really allows you to avoid vendor lock-in, really provides the ability to minimize the complexity with which the tools that you're using. And it's a solution that allows you to really reduce your resource consumption as well as any operating costs that you may have. Okay. So this here is just kind of a quick, highlight of the history of OpenNebula, a little bit of a kind of a roadmap of not necessarily a roadmap, but a placemat, right, of OpenNebula and where it came from. Right, so we have just over 10 years of experience developing and bringing infrastructure solutions to market. And OpenNebula has really developed over this time period with a huge influence by our community of users. There are over 5,000 OpenNebula clouds currently running. The largest of them spans 16 different data centers and has 300,000 cores. And then really, if you look below, you'll see some of the users and customers of OpenNebula spanning all industries. So among other things, this really kind of helps highlight not only its broad flexibility, but also the fact that it's production and enterprise ready. Okay, so while OpenNebula is fully open source, we provide professional value-added benefits that are fundamentally included as part of our subscription offerings. So some of these benefits in our OpenNebula subscription include, an SLA-based support, which is provided through a private portal, right? And this grants you direct access to our support and engineering teams to really, quickly resolve and address production issues, as well as to address day-to-day questions that you may have. The subscription also provides you access with the enterprise edition of OpenNebula, which is a more tested and hardened version of the software, really ideal for implementations in production. It also provides you access to enterprise tools like our OneScape tool, which is built to simplify and automate your software upgrades. And then the subscription also provides you access to the various professional services that are offered by our OpenNebula Systems team. And it also provides access to our curated knowledge base, right, which lines up several best practices, step-by-step guides, and use case overviews, all really designed to keep you current and up to date on some of the valuable insight surrounding OpenNebula. Okay. At this point, I'm going to hand things over to Tino. You can pick things up from here.
Thank you, Michael. Let me share my screen. Okay. Okay, I guess you can see my screen now, right? Okay, so hi everyone. I wanted to introduce you to kind of the general open architecture. By open meaning that it relates with it's the relationship between OpenNebula and other components of the data center that are open source. So mainly the hypervisors, so KVM and LXC and also Firecracker. And also a bit of a deeper insight on the storage support and the different storage options or storage backends, and also obviously focusing on the one provided by LINBIT. Okay, so this is a high-level view of the OpenNebula architecture, managing here you can see also VMware virtual machines that won't be really part of the open architecture, but you can manage with a single instance of OpenNebula also different heterogeneous clusters, right? So you can run KVM clusters and VMware clusters and LXD and also Firecracker clusters with a single OpenNebula instance. Okay, so you can see that you can run virtual machines, obviously on top of VMware and also on top of KVM, but you can also run system containers or even micro VMs, and not only just micro VMs, but you can also run a one-to-one mapping between a Docker container and a micro VM on top of Firecracker, right? So all these this work, it's done by OpenNebula behind the scenes. So you have access to a public marketplace, a Docker registry, like for instance, Docker Hub. You can choose their Docker containers and have OpenNebula automatically download that for you and launch it into a micro VM on Firecracker, on top of Firecracker. You can do the same as well in KVM, but probably the overhead would be too much. So this is a bit of the relationship with different hypervisors. Obviously, OpenNebula also orchestrates networking and storage resources. So we'll see a bit about the storage later on. OpenNebula also integrates with third-party tools, northbound. So you can use interesting stuff like, for instance, Terraform to define infrastructures on top of OpenNebula. That's pretty powerful. Okay. So this is also a high-level view of the different architectures that you can build using OpenNebula. So as you can see, this is the more traditional approach where OpenNebula is managing exclusively resources within a data center. That's the on-premises architecture. This is what we've been doing for past decade, more or less. We also were providing public hybrid drivers, so you could, increase the capacity of your on-prem OpenNebula cloud using the offering of public cloud providers such as Amazon or Azure. So the idea was have OpenNebula the ability to also manage VMs on those public cloud providers. Okay, we've been working lately to a new approach. That's what we call the true hybrid. You can check the URL there for more information. Basically, what we are building, it's the ability to increase the size of an OpenNebula cloud using bare metal offerings of public cloud providers. So this can be seen as growing your OpenNebula cloud in the edge. So you end up with a new OpenNebula cluster within your OpenNebula instance where you can launch your regular workload. You don't need to translate your applications from your on-premises virtual machines to, I don't know, an EC2 virtual machine, which translation is not automatic, but with this new approach, you can define your workload to launch on premises on the edge without any change or any significant change anyway. Okay, so this work about building this edge cloud platform with OpenNebula, it's been funded by OneEdge, which is a project funded by the European Union. And we are using these resources to lead the space on edge cloud platform tools. Okay, so this is a bit how this architecture, this new edge architecture works. It's coming from all the innovation that we did in cloud disaggregation, so the ability to run clouds in different infrastructures or different data centers. Also matching the emergence of this offering in public cloud providers to instantiate not only virtual machines, but also bare metal servers, and the ability to automatically provision them, and also all the automation tools that are available in the space, mainly Terraform. That's the tool that we use to handle the life cycle of these bare metal instances in the edge. Okay, so with all this, we are building this new tool that it's called One Provision, which basically allows you to grow your OpenNebula Cloud clusters with resources on the edge. Okay, this can be dynamically created and also destroyed, so you only pay for what you are consuming at the time, unless you forget. On top of that, all the usual workloads that you can run on OpenNebula, you can also run on the edge. So that this includes the OpenNebula public marketplace, these integrations with other registries like Docker and also LXC. Okay, focusing a bit on storage. So OpenNebula traditionally, well, its architecture allows for supporting different backends, not only storage, but also networking and authentication and many others. But storage in particular allows for a wide range of backends, okay? From the traditional shared file systems like NFS or BlasterFS, or more object-oriented file systems like Ceph, also from devices like iSCSI, or even building LVM on top of that, or even raw database mapping in the host. You have the virtual machine directly accessing the device. Okay, so these are the ones supported by OpenNebula and available in the main OpenNebula distribution. But there's a wealth of add-ons on top of that. I want to highlight the vendor-supported storage add-ons like StorePool and also LintStore, which we'll learn more in a bit. And there's another third-party storage add-ons, not necessarily built by vendors, but by members of the community, which also are contributing value to this ecosystem. Regarding the LINBIT add-on, so you can check it's an OpenNebula hosted add-on. You can check the project page in this GitHub URL. I want to give a shout out to the authors of the driver. So LINBIT guys and gals, Hailey and Vene. Okay, and it's a very mature driver, OpenNebula add-on. It leverages all the features of OpenNebula, so it allows for snapshots, migrations, really fast image clones. So it really adds to OpenNebula instead of giving a subset of the functionality, which is really cool. And also leverage the RTB, which is a fantastic project that I love since I knew it. So it's something that we are very proud to have in our community. Okay, so if you want to try out OpenNebula, if you are a newcomer and you want to give it a spin, there's a couple of really easy ways to try the functionality. If you want to use OpenNebula on top of VMware environment, you can try V1 Cloud, which is an OVA appliance that you just deploy on vCenter, and you're good to go. And then you have Mini1 if you want to build a single node KVM, or even LXD Cloud or Firecracker. It's not supported yet, but it will be shortly. So this is basically one script that you can download really easily and installs OpenNebula for you with a default configuration. So you don't really need to read a lot of documentation to have it running in your premises. And well, we are currently working on the new version of OpenNebula. It's OpenNebula 6.0 that will come with a lot of new features and also stabilize some functionality. But our latest stable release is OpenNebula 5.12. It's called, the name is Firework. And it's also an LTS release. So if you're thinking of running this in production, this is probably your best choice to date. Okay, so yeah, I give pass now to the next speaker. Thanks.
I think that's me, right? Let me share my screen too. All right. Hello, everyone. This is Yusuf speaking from LINBIT, and I'm working for a solution architect in LINBIT. And this is the first company that I worked, and I feel like I'm giving the community what it wants. So I feel very good to work within LINBIT because this is the first company that I worked in open source. All right, so this presentation will give you a little bit more insight about the LINBIT, the RBD, and LINSTOR. And then I will hand over to Andre, that he will show us his great OpenNebula cluster. Okay, so LINBIT is an open source company, and it's founded in 2001. And we have an office in Vienna, Austria. And the other office that we have is in USA, which is in Portland, Oregon. And the company is 100% founder owned. And apart from the offices, both in Austria and USA, we have partners all around the world. And we have a close partner in Japan, which is Sios. And our team of highly experienced Linux experts are developing the source codes of the RBD and LINSTOR. And we have a product, what it's called the RBD, and which basically is doing the block replication in Linux. And our go-to-market is three main products that I can mention here. One of them is LINBIT Disaster Recovery, which is a combination of the RBD and pacemaker, and optionally the RBD proxy here. And the LINBIT HA is another product for high availability solutions, and that's a combination of the RBD and pacemaker, and optionally RDMA. And the last one that we will talk a lot more today is LINBIT SDS, a software-defined storage solution, and it's a combination of LinStore and DRBD for replication. Yeah. Okay. Our teams in LINBIT, where we cover the whole world with an enterprise support, and they are working for 24/7, and we serve on 3 different continents, and we speak in 5 different languages in our support site, and in the feedback given to us by our customers and the open source community, and we stated that they stated that our support engineers talk their language, so that's why LINBIT is really good at giving support to the community. And over these 20 years, and I need to say this, we never missed any SLA with our customers. So in here, I will try to explain what is DRBD a little bit, and then I will jump into the LinStore side. DRBD is our first product, and we have been developing it for 20 years now, and we shape it every day according to the needs of the community. And this product is one of the first pioneers of the block storage world. And basically, it consists a kernel driver and some tools for the block replication. Its main purpose is to ensure the data security and the high availability, high accessibility with replication in Linux subtypes. And with DRBD, we broke the world IOPS record, which is 14.8 million, and we are still working on to break it again. So DRBD has 2 parts. One of them is the primary, and the primary has the data, the primary data in it, primary resource, and it has a secondary, and it can be over 30. The limit is now, the logical limit is 32. So basically you can have 1 primary and 32 replicas in your cluster if you want it. And the replication is happening from primary node to the secondary nodes always. You can do some load balancing within the DRBD, so you can read from multiple secondaries to increase your read IOPS. And the write IOPS is only happening on the primary itself. We also support for some dual primary situations, but that is really, really, really limited scenarios. And we don't recommend to use it except a couple of cases, because it's increasing the inconsistency of the data itself, increasing the risk of inconsistency. And DRBD can work synchronous and asynchronous. So with that synchronous and asynchronous work, it supports on-site and off-site replication. And it is running below the file system. That's why it supports like many applications that you can have. Any kind of workload can run on top of DRBD replication and DRBD devices. And obviously, it can be integrated into a large-scale setups, and it has really good and seamless integration into pretty much everywhere. Yeah, so we all know the problems of the Linux storage management. And while developing the LinStore, our goal was to provide an automation to the storage world to solve this problem. And I think we pretty much hit this. And LinStore is a software-defined storage. And just like DRBD, it is an open source. And it has 2 structures in it. It's 2 parts. One of them is the controller, and the other one is the satellite. And the controller basically manages the satellites, and satellites are installed in each node, so you can manage the raw disk inside of those nodes. And with the LinStore controller, which you can have in a high available one, and with the LinStore controller, you have a LinStore protocol that you can integrate into. And you can manage your LinStore cluster with CLI by yourself, or with the API library and some drivers. For Kubernetes, it's CSI. For OpenNebula, it's a driver, and so on and so on. I didn't write in here, but it supports VMware, OpenStack, OpenNebula, whatever you name it. We have pretty much all of the integrations that you need in market today. But even in LINBIT headquarters, we are using OpenNebula for our cluster, for testing, for everything. So yeah, we are really good. We are really we like the OpenNebula in all ways. So LinStore can scale up to thousands of nodes. There is no limit into that. And it's built on top of the Linux storage system, so it will be effective and easy for everyone to understand and use it. And in the RBD, I mentioned that we hit the world record, which is 14.8 million, and we did it with LinStore, because LinStore is basically leveraging the DRBD, just like Tino mentions. So the replication layer between these nodes is actually happening with DRBD. And LinStore, both controller and the satellite, is stateless. So they are not sitting in the data path. We separated the data path while we're developing it. And that's why you always get away with upgrading, migrating, closing the controller, moving away from one node to another. And that's all you can do without disrupting the data path. And LinStore itself, it has a good optimization with the latest cool guys in the ecosystem, which is NVMe, PMEM, and NVDIMMs, and that's doubling your performance in some cases. And like I told, LinStore is leveraging the DRBD, so it has a synchronous replication, asynchronous replication, and also the snapshot shipping. If you want to do a replication like from one location to another with really a high latency and low bandwidth, snapshot shipping is there for you to help you. And I bet Andre will explain really better than me. And LinStore has a seamless and large scale of integration, which you will see after this presentation. Okay, so while so far I have talked about LINBIT and its products, now I will try to explain why combining LinStore with OpenNebula is a good point. So as LINBIT, we did an integration when we did an integration with a product, and we tried to make it a better, and it's like a fellowship rather than just an integration. And because we know the value of growing together and giving back to back. So in our opinion, two products came together for this purpose. It's not making 1 + 1 2, it's 3 actually. And because a product that is grown by joint effort has many more advantages than it's grown solo. So we have been growing by supporting the open source world since 20 years now, and we will continue to do so thanks to our CEO, Philip Reisner, because he's a really cool guy. Okay, so this is my last slide, and then I will hand over to Andre. So I will try to explain the joint benefits of having OpenNebula and LinStore here. So OpenNebula is an open source platform for building all kinds of infrastructure, which is including the hybrid environments, or even on-premise together. And LINBIT SDS is an open source software-defined storage for high-performance infrastructure, especially. But so when these two come together, it creates the ultimate solution. And OpenNebula is available pretty much for all kinds of Linux distros, as far as I know, if it's not changed. And LINBIT SDS is also available for all kinds of Linux distros, except one or two. And OpenNebula is aimed for a large scale of production environment, and LINBIT SDS aimed for high performance, low latency, and large scale production environment. And we are really good at block storage. And OpenNebula is really good at large scale production. And when these two come together, you will have the best solution that you can have in the market. And both products are open source. And OpenNebula, the installation, the management, everything is simple and efficient as it can be. And same goes for LINBIT. And because of these millions of installations out in the market, and we try to be as much as simple and efficient as we can be. OpenNebula supports for VMs and containers. This also goes for the LINBIT SDS. We are supporting all kinds of workloads. We are supporting all kinds of infrastructures, including the Kubernetes, including the VMware, KVM, XCPNG, you name it, and OpenNebula, obviously. And both systems is providing no vendor lock-in, so you don't have to stick with one vendor, or you can even create your own machines, just like Andre did. And multi-hypervisor support is there for OpenNebula, and LINBIT, just like I mentioned on the above, support almost all operators. Thank you. This was my slide deck. If you have more further questions for LINBIT, you can come by into our Slack channel, and I would be more than happy to answer any questions that you want to know. Thank you.
Okay. Hello, everyone. My name is Andrei Kvapel, and I will say you about our success story of using OpenNebula and LINBIT SDS. First, I have to say that I'm working as a cloud architect and DevOps engineer in WEDOS Internet company. We are biggest Czech hosting company. We have 2 own data centers with own hardware. And we are running thousands of virtual machines, and we have thousands of physical servers. We use servers not only for running virtual machines, we have various types of workloads, but some part also used for OpenNebula and for running virtual machines on these servers. And yeah, we actively use Kubernetes and PXE booting to bootstrap our infrastructure. I'll show you a few photos. This is our data centrum 1 and data centrum 2. The second one is really interesting because we doing crazy stuff there. We are bathing our servers in the oil. You can see that on this short clip. This is done for the better conditioning. So yeah, this looks really amazing, but let's get back to the presentation. First, I have to introduce you our infrastructure. How is it done? We can split it to 2 parts. This is typical cluster. We have control plane nodes, which is running everything need to actually, they are running all the services needed to make other compute nodes working. There is running netboot servers, DHCP server, OpenNebula control plane is running also there, and lead store as well. The rest nodes are running workload. This is typical blades. We use HP Moonshot hardware. It's a kind of chassis with 4 units high. It includes about 45 cartridges. We use HP ProLiant M710X cartridges. So all our compute nodes are very typical. Each cartridge can hold up to 4 NVMe drives. It has 10 gigs network cards, Intel Core, Intel processor, and it can hold up to 64 or maybe even more gigabytes of RAM. So quite interesting hardware. The interesting thing that we have no any operating system installed on it. So all operating system is downloaded directly over the network, direct from the control plane nodes. First nodes, when they turn it on, they download getting an IP address, then downloading image with operating system, and then working, putting it into RAM and working like this. So for update these nodes, we just need to reboot them, and they're not holding any state. After they are booted, first thing which they're doing, it's joining to the Kubernetes cluster. And then we use Kubernetes to deploy some workload on them. So Kubernetes is running Docker containers. And inside these Docker containers, we also have OpenNebula and the lint store. Both deployed are standard Kubernetes workloads. To deploy OpenNebula, we have specific project. It is open sourced and place it on GitHub. It's called Kube OpenNebula. This project allows you simply deploy and try OpenNebula inside the Kubernetes. You just need to have Helm to install it, and you can try it. And the lint store, for the lint store, we also have similar project. It is called Kube Lint Store. This project is deploying all this stuff, all the lint store components directly inside the Kubernetes. This is really useful when you have many nodes. We have hundreds of nodes, and it is easiest way to perform the updates. You're just putting new version of the manifests, and it's running rolling update there. To connect OpenNebula with the lint store, we use own written driver, which is not official one. It is a community-driven driver. I started it by myself, and it is a bit different than official one. First, it is written on Bash, and it uses native OpenNebula library. So it is more native. It calls standard methods, which the other official drivers of OpenNebula calls, and provides error outputs the similar way. The main reason for doing that was that we using lint store, I think from almost from the beginning, and there were no easy option to hide the controller node from the beginning. For now, there is mutual cell authentication, so it's not big problem. But design of this driver is different. It means that you need to have access to the control, to the lint store controller just from the from OpenNebula control plane, and the rest compute nodes actually should have no any access to the lint store. They just should be a member in cluster. They should have satellites installed. So this way, we're using this driver. We have some community. And let's go ahead. And now let's see how is it configured and how is it actually working. This is our OpenNebula dashboard. You can see some numbers here. It is about 2,000 VMs for now. not much persistent images, but we just run our another cloud service, which is, for now, it will be more because we allowed our customers to create the images by themselves and use, we just provide this simple interface of OpenNebula, which is with a LinStore backend. Okay, here is our nodes. Scroll down, we can see there is 262 entities. So each node is created in OpenNebula. It also have to be created inside the LinStore with the same name. And after that, we can check the data stores. OpenNebula here has two kinds of data stores. It's called images and system. This terminology is kind of standard in OpenNebula. And both these images, both these data stores are using the same resource group, the same configuration for placing the resources inside the LinStore. You can see here is resource group OpenNebula 1. This is important. I will explain you why. Let's see the same option in the command line. We see resource group OpenNebula 1. And now we can access a LinStore through the CLI. For now, I just listed resource groups in the LinStore, specific resource group, which is named OpenNebula 1. So resource group is specific resource which is holding all needed parameters to place your volumes inside the hardware, inside your cluster. We can see that there is set a placement count 2. This means that we need 2 replicas for each volume created, and it will be always created in the storage pool with the name thin data. And there is also 2 interesting parameters which we're using quite high. It is replicas on same and replicas on different. First is used, as I say, we're running various types of workloads, and we have nodes which is not belong to the OpenNebula. But all OpenNebula nodes has this parameter set. So we can, this way we can just select nodes dedicated for the OpenNebula. And the second parameter is replicas on different. It means that replicas should be placed on different types of chassis, not types, but in different chassis. This is always better for the redundancy. And I will show you. Okay, I can select some nodes with dedicated for OpenNebula this way. And we can see some properties, for example, for these 2 nodes. We see that M13C4, this is node from chassis Moonshot 13. And M15C4 is node from Moonshot 15. Actually, this is just parameters which is used for dynamically placing the resources. Let's see how's it working. Yeah, we can also select it like this way, like nodes just from Moonshot 13. And now let's see how the resources place it. For example, this is resource of one of virtual machine, disk 0. It is placed in these 2 different nodes. You see it is up-to-date disk-full replicas. They're placed on these 2 nodes, and they are actually located on 2 different physical locations. And the third replica is diskless replica. This is actually where virtual machine is running right now. So each time when you're running virtual machine, you can run it everywhere in your cluster. Just before that, the driver will create the diskless replica, which will just redirect I/O to the disk-full replicas. And yeah, we can also check some standard resource created in images data store. This is just standard image. For example, if you uploaded some ISO, it also will get into lint store. Even checkpoint files, if you're suspending your virtual machine, it can also be stored in the lint store. So you don't need any shared file system to for the redundancy. This driver is ensures that fully. And now just let's watch a little numbers. Resource amount, we have 2092 resource definitions created in OpenNebula by OpenNebula. It means all the images of virtual machines, of the images and ISOs, and even also checkpoint files. And we can also check a full amount of replicas created for them. It means disk-full and diskless replicas like here. You see that each resource definition can have more than one resource. So we have 6,126 replicas resources created, disk-full and diskless. That's probably it. And the smallest part I want to say about the backups, because it is also so important. For now, lint store has really cool feature, which is called snapshot shipping. I would to suggest it to you as well, but we started using lint store even before that. So we have own solution, which is based on Restic. And I found that it is really interesting and it is really a good working solution because Restic allows you to backup block devices as well standard files and file systems. And it has deduplication, which is working out of box. So we have some big storage, which is using ZFS derate feature. And we just shipping all our volumes directly to it. For making better consistency for each virtual machine before the backupping, we also creating the snapshot. And after the backup is done, snapshot is getting to removed. So this is probably it. This is our success story. Thank you for listening.
Excellent. Thank you, Andrei. Thank you, Yusuf. I think now we're going to essentially move into the Q&A section. So if you folks have any questions that you want to submit through the chat, please make sure to do so. We'll be, we can answer some of those now. Let's see.
So I see a question that is asking, wouldn't it be faster to run workload from disk-full node rather than using diskless node? I can clearly say that actually diskless nodes are a little bit faster on disk-full node on DRBT because it's taking some of the weight in the CPU. So, and it's running really good. And even lately, we did some of the testing on disk-full over diskless node with a couple of great NVMe devices. And it turns out diskless nodes are like, let's say, 10% faster than disk-full nodes in some cases. Lint store versus Ceph. In which terms, even? Can you elaborate the question a little bit? So maybe I can.
Yeah, we'll wait for that participant to provide some more details there.
So I have a question for you, Yusuf. I know that lint store has a vSAN solution. Is the lint store driver of OpenNebula compatible with such a solution, or is something? It's a different beast?
It's called vSAN because it basically allows us to create vSAN-like environment, and it's basically consists of one OVA file and ISO image that you can upload into any hypervisor. So, and it's providing an iSCSI target and LFS target, I think close enough. And so you can integrate into OpenNebula or something else. It's not directly integrated into OpenNebula, so you have to do the work and bind it into the OpenNebula.
Okay.
It's more focused on, let's say, VMware and Hyper-V kind of workloads.
Yeah. Okay. Okay. Thank you.
There were a question about the disk-full nodes. Wouldn't it be faster to run workload from the disk-full node rather than using diskless node? That's actually faster. And this driver, my driver, is supporting this as an official one. So by default, it has an option that you can enable placing resource in the same place where VM will be running. And for the future, as I know, OpenNebula team wants to implement a custom scheduler, which will also support scheduling virtual machine afterwards. So after a while, when you place a virtual machine, it can be used the disk-full node by default, but in the future it also will be used. It also will be allowed to automatic place virtual machine always on this node. So this opportunity will be available in the future releases of OpenNebula.
I think there's a question about how soon is OpenNebula 6 coming out. So we are working on the beta release that should be available within 2 weeks' time. And we are aiming for the final stable 6.0 at the end of February. So about new protocols for remote console. So yeah, there's a couple of new stuff there. One is support for PMRC, so that's the VMware Remote Console Protocol. Since vSphere 7.0, it's going to drop VNC support, so we had to come out with that support. And also we are integrating with Guacamole, that provides a better VNC experience, and also RDP and SSH capabilities.
Okay, I can also answer on one question, LinStore versus Ceph. As third-party person, I think I can say some words here. I would say about pluses and minuses of the LinStore in comparison with the Ceph. First, I can start from the minuses. That in the LinStore you can't squash the drives across the all nodes, so you can't create the drive which will be actually more than one physical node size. But as about pluses, I can say that it is much easier and it's much more difficult to lose your data. For example, if you have no LinStore control plan working, you can still access your data. Even if DRBD isn't working, you can take your backend devices and take some data from that. And this is really cool. We had a story.
Andre, yeah? This is what we intend to do in the beginning. That's why it's designed that way. You can, yeah.
I just want to say that LinStore is more simpler and faster solution in case if you don't need to combine more IOPSes from the many nodes. But in case of ZCF, you usually need to have separate cluster. You can't, you would never run Ceph on the same nodes where you're running virtual machines because will be a really bad idea. In case of the LinStore, you can do that with no problems.
One more question from Johanjo, I think I'm pronouncing correct. Sorry if I didn't. He says, in the website of LINBIT says that LinStore is block storage management for containers. but my question is if it's also appropriate for VMs. So it's a yes. It has a support for both containers and VMs, and from Andrei's approach, you can clearly see that we have support for both of the worlds.
Yeah, we're actually using LinStore with the various platforms. For now, we have 3 running. It is actually Proxmox, OpenNebula, and also Kubernetes. And of course, inside the one system, the devices management is usually similar. For example, in OpenNebula, you can use the same driver to manage LXCs and also the virtual machines.
Another question to you. Do you have a different network interfaces for storage replication? What bandwidth?
Yes, actually we have, but we use bonding, and then we use different VLANs. And we have specific VLAN interface just for data networking. And one is actually for the management. One is used for OpenNebula communication from control plane to the nodes and from the LinStore to control plane nodes. And the second interface is used just for DRBD replication. What bandwidth is 10 gigs network?
10 gigs, that's good. That's good. Ivan asked about, can you tell us more about REST backups?
Yes, as about REST backups, I can send you a link. I wrote a big article about that. Just a second. Send it to everyone. Yes, here is a link about article how I was using the RESTIC to perform block device backupping in this binding OpenNebula and the LinStore. So we have some Ansible playbook which is running in a loop and running RESTIC. First, it creates snapshot in the LinStore, then makes a resource from this snapshot, and then this snapshot is fully read by the RESTIC. And if there are any differences found according to the previous backup, it will send these deltas to the backup server. So very simple, and it is working as a charm.
And let me add this into this context. We are currently developing this snapshot shipping into S3 backends. So it will be an easy way to put the backups into S3 storages in LinStore in the close future.
Yeah, it should be a really interesting future because for now, OpenNebula has no interface just for the backups. And I think that using OpenNebula and LinStore together will provide complete solution for all this stuff.
Okay.
I was playing a little with this feature in the LinStore that you can just specify schedule where you want to ship the snapshots and when, and it will automatically ship the snapshots to these nodes. On which Linux distros the solution one and LinStore are available?
Pretty much all of it.
Yes, but mainly Ubuntu. As about LinStore, there is there is ready packages in Ubuntu and Debian, Proxmox, and the rest distros you have to compile or use
Use
what's it called?
You use
LINBIT support.
repositories.
Yes.
Yeah.
Yeah, as about OpenNebula, it is actually Ubuntu, Debian, CentOS, and OpenSUSE, even if I remember it correct. So all standard distros are supporting OpenNebula. What about me? The question is, what distro do you use? We are using Ubuntu. Just because we're using LTSP project, which is really easy to start this Pixie booting farm. So we have full system compiled through the Docker file, and then we distributing it to the physical nodes the same way like Docker containers.
I also want to say through LINBIT subscription, LINBIT SDS is available on all of them pretty much in RHEL, Ubuntu, and Fedora, whatever you want. Yeah.
And yeah, there were project which is called Piraeus. I thought it's just one operator which you can click and install in your Kubernetes cluster. And it also will inject the DirbD module. It's kind of interesting.
All right. Well, I think this leaves us at a good spot to wrap things up. One thing I want to let everybody know is that in a few days' time, we'll be posting the recording of the session on our website at OpenNebula.io. I'd like to thank both Joseph and Andre for showcasing and sharing your expertise and joining us today. Also want to thank all of you, the rest of you participants for joining us and actively participating here in our webinar. Like I said, keep your eyes peeled for upcoming webinar events. As Tino pointed out, OpenNebula 6.0 is going to be coming soon as well, so you'll be seeing some communications related to the 6.0 release in the coming weeks. So once again, a big thank you to you all, and hope to be seeing you guys all soon. All right. Thank you, everyone.
Thank you.
Thank you.
Thank you. Bye.